Hi everyone, and welcome to our video on the magnitude of a vector. So the magnitude of a vector is its length, and it's denoted using the absolute value or a double absolute value. So it depends again kind of on the person's style or the book. I think majority of the time they use the first style, just like the absolute value. But still in vectors, we call it the magnitude, which is a length. All right, so if we're going to find the magnitude of v, I mean, you could sketch it. Let's see it in a sketch. Okay, so we've got 3i minus 4j. So here they did it in terms of I and j. So 3i means you need to go right 3. Negative 4j means we would go down 4. And then from our origin is the easiest way to do it. There we go. That's the vector v. And then what they want is the length. Well, I can make a right triangle. There's 3, there's 4. Okay, so this is a special right triangle. You might see it right now. It is going to be 5. But let's go ahead and state what is currently going on with this. So the vector v, in case we wanted to rewrite it in a special formula, is the square root of the x component squared. Okay, so I'm just going to say x squared plus the y component squared. Okay, so it is Pythagorean's theorem, really. So this is a, this is b, here's c. So a squared plus b squared equals c squared. There's c, that's what c would have been. And then all we're doing is just converting our notation. Square root both sides would give us the square root of a squared plus b squared is c. And we would instantly choose the positive because we're looking at a length. Okay, so for habit's sake, plus minus, but we would choose the plus. And then because we're dealing with vectors, we know c is a length. Length of a vector, though, we change it to the magnitude notation. Okay, and still, there we go. Okay, so that's where it comes from. Okay, so but I chose to do x and y, like the x component, y component. And so on our problem, again, we already had the answer, but just to fill it in, we would have had 3 squared plus negative 4 squared, all under a square root. 3 squared is 9. Negative 4 squared is 16 still. So 9 plus 16 is 25. Okay, so there's the square root of it all. There's our magnitude. Okay, so the magnitude of v is 5. All right, so let's see number 2. On number 2, we have the magnitude of u plus v. All right, so that does mean we need to do the order of operations first. All right, so and you could sub them in. So here they're doing the double absolute value, but you don't need to do the double absolute value. I am just going to sub in 6i plus 2j, and then plus v is 3i minus 4j. In double absolute value, there we are. And then let's simplify it. So still double absolute value. 6i plus 3i would be 9i. 2j minus 4j would be minus 2j. Okay, so that's what that looks like inside there. Still, we can always make a sketch. So 9 to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then down 2 is the length, and that can help remind us that we are just doing Pythagorean's theorem. There's a length of 9, there's a length of 2. Okay, however, if I wanted to keep it with our new square root just notation, I could say, well, I could take the horizontal component, 9, square it, plus the vertical component, negative 2 squared, and keep it all under a square root, and then just continue with the order of operations. Okay, so it's up to us. Okay, so here we've got the square root of 81 plus 4. Negative 2 squared is positive 4. And then that simplifies to be the square root of 85. And then that's as good as that gets unless they want us to use a calculator, and then we could just plug it in. But that is how we can find the magnitude of a vector. Okay, so sometimes we might need to do a little bit of order of operations first, but that is the final answer there. Okay, so the next part, I'm actually gonna let's keep this video nice and short. Well, let's do the magnitude and direction in another one. Thank you for watching. I'll see you again soon.